Bismillahirrahmanirrahim. Dear cadet, Assalamu alaikum. Welcome in the new chapter, chapter number 2, Theory of Quadratic Equations. So in this chapter, the first topic is discriminant, then nature of the roots, then formation of quadratic equation. So we will study one by one. The first topic is discriminant. So discriminant of the quadratic equation. So what is discriminant? The quantity under radical sign in the quadratic formula, that is b square minus 4ac. Quadratic formula is x is equal to minus b plus minus b square minus 4ac under root divided by 2a. So b square minus 4ac in the term under the radical sign, that part is called discriminant of the quadratic equation. So if b square minus 4 is equal to 0, mean there are three cases for discriminant of a quadratic equation. If we find where a, b, c are the constant, so in any quadratic equation we first of all find the value of a, b, c, that is coefficients of x square, x and constant term. Then we will find the value of b square minus 4ac. To b square minus 4ac there are three cases. If the value of b square minus 4ac is equal to 0, then the roots of the quadratic equation will be equal and repeated, same. If b square minus 4ac is greater than 0, for example 1, 2, 3, 4, etc., then the roots will be unequal and real. And if b square minus 4ac is less than 0 means negative number, then the roots are unequal and complex, or conjugate roots, or imaginary roots. So there are three cases. And if b square minus 4ac, for example, that equal to positive number, and positive number may be 3, 5, 7, that is not a perfect square, or for example perfect square 4, 9, etc. Then there are two cases. If b square minus 4ac is greater than 0, positive number, and it is a perfect square, then the roots will be rational. If it is not a perfect square, for example 3, 5, 7, etc., then the roots are irrational. So for example, come to example number 2, part first. Find nature of the roots of this quadratic equation, x square minus 8x plus 16 equal to 0. So given comparing this equation with the standard form of quadratic equation, we get value of a is equal to 1, b minus 8, c 15. So discriminant b square minus 4ac. Put the value of a, b, c in the discriminant. The b value of b is minus 8 square minus 4 into a value 1 and c value 16. Here c is 16. So minus 8 square 64 minus 4 16 is 64. 64 minus 64 is equal to 0. So therefore the roots of the given equation are real, and 0 is a perfect square, rational and equal by first case. So similarly we can find the discriminant of the equation and decide the three cases. If it is 0 like this, then the roots are real, equal, and if it is perfect square, then the roots will be rational. Next, example 2, part 2. Find the nature of this quadratic equation, x square plus 9x plus 2 equal to 0. So comparing this equation with the standard form of quadratic equation, we get a1, b9 and c2. So discriminant we find the discriminant b square minus 4ac, putting the values of a, b, c. 9 square minus 4 into a value 1, c is 2. So that become 9 square 81 minus 4 to the 8. 81 minus 8 is equal to 73, greater than 0. But 73 is not a perfect square. So the roots are the given roots of the given equation are real. It is not a perfect square, so irrational and unequal. If it was a perfect square, the number was perfect square, then the roots will be rational. Next, the same example 2 part 3. Find nature of the roots of this quadratic equation. So comparing this with the standard form, we get value of a 6, b minus 1 and c minus 15. Discriminant b square minus 4ac, putting the values of a, b, c in the discriminant, we get 1 minus 1 square 1 and minus 4ac. To minus 15 minus 4 become positive, that is plus 360. 1 plus 360, 361. But 361 is a perfect square because 19 square is equal to 361. Therefore, the discriminant is greater than 0 and it is a perfect square. So if it is a perfect square, then the roots of the given equation are real, rational and unequal. So for perfect and not perfect, only rational and irrational we use. If it is a perfect square, then the roots will be rational. If it is not a perfect square, then the roots are irrational. Remaining case is the same. If b square minus 4ac, that is discriminant equal to 0, then the roots are real and equal. Greater than 0, then the roots are real and unequal. If less than 0, then the roots are imaginary or complex. Fourth part, find the nature of the roots. So given quadratic equation is 4 square plus 6 plus 1 equal to 0. By comparing, we get a4, b1, c1. Discriminant b square minus 4 is putting the values 1 square minus 4 into 4, a value 4 and c value is 1. So 1 square 1, 4 4 is 16, 1 minus 16 minus 15. Minus 15 is less than 0. So the third case, therefore roots of the given equation are complex, conjugate or imaginary and unequal. So all the three cases are solved. So there are three cases for discriminant of the equation or for the nature of, to find the nature of the roots of the quadratic equation. Now come to exercise. Find discriminant of the quadratic equation x square minus 4x plus 13 is equal to 0. So since x square minus 4x plus 13 is equal to 0, it is in standard form. Comparing with the quadratic equation, standard form of quadratic equation, ax square plus bx plus c equal to 0, we get a, that is 1, coefficient of x square, b minus 4, coefficient of x, and c constant term, that is 13. Therefore discriminant is equal to b square minus 4ac, putting the values of a, b, c in the b square minus 4ac. So value of b is minus 4 square minus 4 into value of a1 and value of c 13. Minus 4 square 16 minus 4 13 for the 52. So 16 minus 52, that is minus 36. So that is discriminant of the given quadratic equation. Part 2. Find discriminant of this quadratic equation 4x square minus 5x plus 1 is equal to 0. Since 4x square minus 5x plus 1 equal to 0, a standard form of quadratic equation. So comparing this with the standard form of quadratic equation ax square plus bx plus c is equal to 0, we have coefficient of x square a 4, coefficient of x, that is minus 5, b, and constant term c is equal to 1. Now putting in the discriminant b square minus 4ac, Value of b minus 5 square minus 4. Value of a is 4 and c is 1. Simplifying, minus 5 square 25 minus 16. 25 minus 16 is equal to 9. So discriminant of this quadratic equation is equal to 9. Thus we can get different discriminant. It may be 0, less than 0, greater than 0. It may be perfect square or non-perfect squares. Now question 2. Examine nature of the roots of this quadratic equation. So for the nature of the quadratic equation, we find the discriminant and then decide the nature of the roots. The discriminant, all the three cases. So which case the given equation satisfies. For example, comparing this quadratic equation, first of all, it is in standard form. So comparing this with the standard form of quadratic equation, ax square plus bx plus c. We have a is equal to 3, b is equal to minus 5 and c is equal to 1. Thus putting the values of a, b, c in the discriminant b square minus 4ac. b is minus 5, so it becomes minus 5 square minus 4 into a value 3 and c is 1. Therefore minus 5 square 25 minus 4 3 is 12. 25 minus 12, 13, greater than 0. It is greater than 0 but not a perfect square. Therefore roots are real, not a perfect square, so they are irrational and unequal. Next, question 2, part 3. Examine nature of the roots of this quadratic equation, 3x square plus 2x plus 1 equal to 0. So comparing this quadratic equation with the standard form of quadratic equation, ax square plus bx plus c equal to 0. We have a is equal to 3, b is equal to 2 and c is equal to 1. Putting a value of a, b, c in the discriminant, b square minus 4ac. So value of b is 2, 2 square minus 4 into a is 3 and c is 1. So 2 square 4 minus 4 3 is 12. 4 minus 12 minus 8. Minus 8 is less than 0. So third case, a is b square minus 4ac is less than 0. That is discriminant is less than 0. Therefore roots are imaginary and unequal. Or imaginary mean complex conjugate or complex roots. Let's come to question 3. For what value of k the roots of x square plus kx plus 9 is equal to 0 are equal? In a given quadratic equation is in standard form, x square, x in constant term. And given that for what value of k, mean find the value of k. The roots of the equation are equal. So given condition is the roots of this equation are equal. So the roots of any quadratic equation will be equal if its discriminant is equal to 0. So using that property, comparing this quadratic equation with the standard form of quadratic equation ax square plus bx plus c equal to 0. We have a is equal to 1, b is equal to k and c is equal to 9. As the roots are equal, therefore discriminant b square minus 4ac is equal to 0. If it is given that the roots are unequal and real, then discriminant we take greater than or equal to 0. If it is given that the roots are imaginary, then b square minus 4ac is less than 0. So the first case is the roots are equal given in the question. Therefore by that property discriminant is equal to 0. So putting values in the discriminant, value of b is k square minus 4 into a into value of c 9 is equal to 0. Simplifying this one, k square minus 4 9 is 36 is equal to 0. Transforming minus 36 to right hand side, k square become 36. Taking square root on both sides. So square cancel with square root, this means k is equal to plus minus 6. Thus we get the value of k. So using property we will get the value of k. Similarly, part 2 of question 3. For what value of k the roots of this quadratic equation 12x square plus kx plus 3 is equal to 0 are equal. Again condition is equal. So comparing 12x square plus kx plus 3 equal to 0 with the quadratic equation, standard form of quadratic equation, ax square plus bx plus c is equal to 0. We have a is equal to 12, b is equal to k, c is equal to 3. As the roots are equal, therefore discriminant of the equation b square minus 4 is equal to 4ac is equal to 0. Putting the values of a, b, c in the given discriminant. K square minus 4, a value 12 and c value 3. Simplifying, k square minus 4 3 is 12 and 12 2 is 144. K square minus 144 is equal to 0 implies k square is equal to 144. Transforming minus 144 to right side. Are taking square root on both sides. So square root of k square become k and square root of 144 become plus minus 12. Thus we get the value of k is equal to plus minus 12. Now come to question 4. Determine whether x square plus 5x plus 5 is equal to 0 have real roots, and if so, find roots. And first of all, we have to find whether the roots of this quadratic equation are real or not. If the roots are real, then find the roots. That is the question. So first we compare the given quadratic equation x square plus 5x plus 5x plus 5 is equal to 0 with the standard form of quadratic equation ax square plus bx plus c equal to 0. We get a is equal to 1, b is equal to 5, c is equal to 5. So to check the nature of the roots, discriminant of the given equation, first we find the discriminant b square minus 4ac. Putting the value of a, b, c in the discriminant, we get b square in 5 square minus 4 into value of a1, value of c is 5. That become 5 square 25 minus 4 5 are 20. 25 minus 25. 5 is greater than 0. A is b square minus 4ac is greater than 0, but not a perfect square. So therefore roots are real, unequal and irrational. Now we prove this property. That was without solving a quadratic equation. We find the root, we find the condition, what type of root of this quadratic equation have. So without solving, by discriminant, we found that roots of the given equation are real, unequal and irrational. Now by practical solution, solving this quadratic equation, given quadratic equation, we verify our answer. Either really it is the roots are real, unequal and irrational. So by quadratic formula, we solve this quadratic equation, the given quadratic equation x square plus 5x plus 5. So again putting the value of a, b, c in the given quadratic equation. X is equal to minus b and minus 5 plus minus value of b is 5. 5 square minus 4 into 1 into c divided by 2a, 2 into 1. Simplifying, minus 5 plus minus 5 square 25 minus 4 5 is 20 minus 20 under the root divided by 2. Or x is equal to minus 5 plus minus 25 minus 25 under root over 2. So 5 cannot be simplified, therefore minus 5 plus 5 under root by 2. We get 2 roots, and minus 5 minus 5 under the root by 2. There are 2 roots which are unequal, they are not equal because one is positive, one is negative. And irrational because the roots are irrational, there is one third are irrational number under root 5. So we verified the answer. First of all, we found by discriminant. We found by discriminant of the equation that the roots are real, unequal, and irrational. And then their verification of the given question, we solve this by quadratic formula and practically get two roots which are unequal, irrational, and real roots. Next, come to question 4, part 3. Determine whether 6 square plus 6 minus 2 is equal to 0. Have real roots, and if so, find roots. So determine, we have first of all by discriminant of the equation we solve, and without solving the equation we we will find the roots of the given quadratic equation. Either they are equal, unequal, rational, irrational. So by checking, comparing this given quadratic equation 6 square plus 6 minus 2 equal to 0 with the standard form of quadratic equation, we have a is equal to 6, b 1, and c minus 2. That is the coefficients of x square, x, and constant term. To check the nature of the roots, therefore we check the nature by the discriminant of the quadratic equation. So discriminant is b square minus 4ac. Putting values of a, b, c in the discriminant is equal to b value is 1 square minus 4, a is 6, and c is minus 2. Simplifying, 1 square 1, minus become positive, multiply, so minus 4 into minus 2 plus 8 6 are 48, 1 plus 48 49. 49 is the square of 7, or we can write 7 square. A is b square minus 4ac is a perfect square. Therefore, the perfect square and greater than 0. So the roots are real, unequal, and rational. Since the roots are real, so we will solve the equation further. Because it was a condition in the given question, if the roots of this equation are real, if so, then find the roots. Now we will find practically by solving this quadratic equation by quadratic formula, or by factorization, or by completing the square. So we solve this equation by factorization. 6 square and split plus 6 into 2 factors, plus 4 minus 3. If we add, we get plus 1. If we multiply, 4 3 the minus 12. That is the product of AC, coefficient of x square and constant term, 6 to the minus 12. So splitting that factor into 2, 6x square plus 4x minus 3x minus 2 is equal to 0. In first two term, 2x is common. We get 3x plus 2 into 3x plus 2 minus 1 common in the next two terms. Minus 1 common, we get 3x plus 2. Now 3x plus 2 is common to both the term. So 3x plus 2 common, we get 2x minus 1, another factor. So by the same principle, if product of two factor equal to 0, this means each factor 2x minus 1 equal to 0 and 3x plus 2 is equal to 0. Solving these two factors, 2x is equal to 1, or divided by 2, we get x is equal to 1 by 2. Similarly, 3x is equal to minus 2, transforming 2 to right hand side, or divided by 3, we get x is equal to minus 2 by 3. Therefore, solution set is 1 over 2 minus 2 by 3. So 1 over 2, by checking, the roots are unequal and rational, which is verified by solving this quadratic equation practically. Now come to question 5. Determine nature of the roots of this quadratic equation 3x square minus 10x plus 3 equal to 0, and verify result by solving them. First of all, determine nature of the root. We find the nature of the roots of this quadratic equation. To check the nature of the roots, comparing 3x square minus 10x plus 3 equal to 0 with the standard form of quadratic equation. We find A is equal to 3, B is equal to minus 10 and C is equal to 3. That is the value of ABC. Therefore, putting in the discriminant b square minus 4ac, value of ABC is equal to minus 10 square, that is value of b, minus 4 into value of a is 3 and c, value of c is 3. Simplifying, minus 10 square 100 and minus 4 3 the 12, 12 3 the 36, minus 36 is equal to 64, and 64 is the square of 8, which is a perfect square. So discriminant b square minus 4ac is greater than 0 and it is a perfect square. So is b square minus 4ac is a perfect square, therefore roots are real, unequal and rational. Now verification. For verification we solve the roots are, since the roots are real, unequal and rational, therefore we solve the given quadratic equation. So solving this quadratic equation by factorization. You can solve this by any method. Which one is easy to you? So 3x square minus 10x plus 3 is equal to 0. Split the middle term into 2. Minus 9 plus minus 1. So minus 9 minus 1, by adding we get minus 10, and by multiplying minus 9 minus 1 we get plus 9, which is the product of AC, that is coefficient of x square and constant term. So putting these instead of minus 10 we write two terms, that is 3x square minus 9x minus 6 plus 3 equal to 0. In the first two, 3x is common. So taking 3x common we get x minus 3. Again minus 1 is common to next two terms, we get plus x and minus 3. So x minus 3 is common to both the terms, both the factors. So x minus 3 common, we get 3x minus 1, another factor. This product of two factors equal to 0 mean each factor is equal to 0. Either 3x minus 1 equal to 0 or x minus 3 is equal to 0. So solving these two factors, 3x is equal to 1, transforming minus 1 to right hand side, or divide by 3 we get x is equal to 1 by 3. Similarly solving this, transform 3 to right hand side, x is equal to 3. So we get two roots, that is solution set, 3 and 1 by 3. So by checking 3 and 1 over 3 are unequal and rational, which is verified. That was the proof by practically solving the questions. Now part 3, question 5. Determine nature of the roots of x square minus 3 equal to 0 and verify result by solving them. So first write this equation in standard form. Standard form of this quadratic equation is to check the nature of the roots of the given equation, comparing x square minus 3 equal to 0 with the given quadratic equation ax square plus bx plus c. So a is equal to coefficient of x square, that is 1. B is equal to 0 because there is no x term, or we can write this first in x square plus 0 x minus 3. So quotient and b is equal to 0, that is coefficient of x is equal to 0, and c is equal to minus 3 constant term. So the discriminant of this equation b square minus 4ac, putting the value of abc in the discriminant. B value is 0, 0 square minus 4 into value of a is 1 and value of c is minus 3. Simplifying, 0 square 0 plus the minus minus become positive, minus 4 3 is minus 4 multiplied by minus 3, we get plus 12. So is equal to plus 12. A is b square minus 4ac is greater than 0 but not a perfect square. Therefore roots are real, unequal and irrational because it is not a perfect square. So now verification. For verification of this question we solve the given quadratic equation x square minus 3 is equal to 0. So by simply transforming minus 3 to right hand side, we get x square is equal to 3. Taking square root on both sides. So x is equal to plus minus under root 3. Under root 3 is irrational number. And the two roots plus under root 3 and minus under root 3 are different. They are not equal. Therefore, the solution set that is we get two roots under root 3 and minus 3 under roots. So the roots are unequal and irrational. Now, sixth question, part 1. For what value of k the roots of this equation 2 square plus 3x plus k is equal to 0 are real and b imaginary. So for what value of k we have to find the value of k. In first case if the roots are real, and second case if the roots are imaginary. So we take one by one. First of all, comparing this quadratic equation, given quadratic equation, with the standard form of quadratic equation ax square plus bx plus c equal to 0, we have a is equal to 2, b is equal to 3 and c is equal to k. That is the value of a, b, c. Now for first condition, if the roots are real, so for real root the condition is b square minus 4ac is greater than or equal to 0. So if roots are real, then b square minus 4ac is greater than or equal to 0. So implies putting the values of a, b, c in the given condition. Value of b is 3 square minus 4 into a. Value of a is 2 and c. Value of c is k is greater than or equal to 0. 3 square 9 minus 4 to the 8k is greater than or equal to 0. Or 9 transforming minus 8 to right side, that become positive. 9 is greater than or equal to 8k. Or dividing by, we have to find the value of k, so divide both sides by 8. So we get 9 by 8 is greater than or equal to k. Or we can write this, we read any inequality by two-sided. We can say 9 by 8 is greater than or equal to k, or k by this side we read this as k is less than 9 by 8. So we can write this as k is less than or equal to 9 by 8. This means the roots of the given equation will be real if value of k is greater than or equal to 9. Or by putting value of k less than 9 by 8 or equal to 9 by 8 in the given equation, the given quadratic equation becomes such that its roots will be real. This is the meaning of the question. Next, for what value of k means find the value of k if the roots are imaginary. So for b parts, if the roots are imaginary, then what is the condition? The condition for imaginary root is b square minus 4ac is less than 0. So applying this condition, putting the value of a, b, c in the given condition, that is b square minus 4ac, 3 square minus 4 into value of a is 2, c is k is less than 0. Simplifying, 3 square 9 minus 4 to the 8k is less than 0. Or 9 transforming minus 8 to right side, this become 9 is less than 8k. Now we have to find the value of k, so divide both sides by 8. This become 9 by 8 is less than k. Or we can read this as, from this side if we read, we can say k is greater than 9 by 8. Or we can simply write k is greater than 9 by 8. So there are solution set consists of two conditions. The roots of this equation will be real if k is less than or equal to 9 by 8, and imaginary if k is greater than 9 by 8. This means if we put any value greater than 9 by 8 in the given equation to replace k, then the roots of this quadratic equation will be imaginary. Thank you so much. That is the end of today's topic, exercise 2.1. In the next class, we will start the new topic, cubic roots and exercise 2.2. Thank you so much. Allah Hafiz.